rate of change of separation. Okay, suppose we have two particles A and B and they are separated by a distance s, and suppose B is moving with some velocity 2 meter per second as shown, A is fixed. Then obviously the separation will increase and therefore d by dt of s will be positive because the separation is increasing and it is increasing with the rate 2 meter per second. Okay. Now consider another situation. Now B is again moving with 2 meter per second as well as A is now also moving 5 meter per second. Now this separation S, if you consider one by one, its rate of change will be plus 2 because when B moves, separation increases. So the velocity of B is increasing the separation, so it comes with a positive sign. While when A moves, it will decrease the separation and therefore its velocity will come with a minus sign. So overall it's a negative quantity that implies that separation will decrease with time and with the rate 3 meter per second. Okay, again suppose we have two particles A and B, and suppose B is moving along a circle, then obviously its velocity at the position shown will be along the tangent to the circle, and that velocity will be perpendicular to the radius, that is the separation. So this velocity will not change the separation because the separation will always remain equal to radius, and therefore d by dt of s due to this velocity will be 0. So what we learn here that if we have two particles and suppose one of the particle happens to be moving in a direction perpendicular to the line joining the particles, then this velocity will not change the separation at this instant. So d by dt of s will be 0. Now consider a more general situation. A and B, again two particles separated by s, and suppose we happens to be moving at some angle making with the line joining A and B, and let this angle is theta. Now in this case what we can do, we can resolve the velocity into its two components, one perpendicular to separation, that is the line joining A and B, here v sin theta, and another along the separation, that is v cos theta. V sin theta component will not produce any change in s because as seen above it is perpendicular to the line AB. So we can just ignore that v sin theta. So d by dt of s will be only due to v cos theta, and v cos theta happens to be in such a direction in which when B moves the separation increases, and therefore v cos theta comes with a positive sign. Okay. We take one example. A is fixed, B is a particle, and suppose B happens to be moving always with same speed but making an angle theta, suppose 60 degree, and this angle is always 60 degree with the line AB. So V is always such that it makes an angle 60 degree with the line AB at that instant. So as line AB turns, so does this velocity V, the direction of V, and it's always making 60 degree. So it will follow a curved path like this, and ultimately it will go to A, it will reach to A. So suppose we have a question which asks how much time will it take for B to reach to A, then how to solve this? If A and B are separated by A initially, so this A in the question is given as the initial separation. Now we take a general situation. Suppose A and B are in general at these situations, and they are separated by a distance s, and V has a component V cos 60 and V sin 60. If we do the components, so one will be V cos 60, the other will be V sin 60. V sin 60 we can ignore being perpendicular to AB, so I am just deleting it. V cos 60 is in such a direction that it will decrease the separation, so it will come with a minus sign. So this equation suggests that separation is decreasing every second by an amount equal to v by 2. So if we cross multiply, so it will come equal to this, then integrate both sides. When time is 0, initial separation is given as a, so these are the limits, lower limits. When time is t, then separation becomes 0. So I am taking time t as that time in which a and b meet, and on solving this we get that time. So that time is 2a by v. Okay. Just take one more example. There are three particles at the three corners of an equilateral triangle of side A, suppose, and one is moving towards 2 with speed u, 2 is following 3 with speed u, and 3 is following 1 with speed u. After some time, 1 and 2 and 3 will change their positions, and according to their new positions, 1 will again follow 2. So now 2 has changed its position. So 1 will change, particle 1 will change the direction of its velocity, and it will be towards the new position of 2, and the new position of 2 is here. So its velocity will be in this line, and similarly every particle will follow the next particle and the new position of the next particle, obviously, and so on. So these particles will follow a curved path, and ultimately they will meet at the center. So question is time after they meet. So what time do these particles take when they meet? Okay. So consider a general situation. Suppose on their paths, particle 1 has reached to this position. Similarly, particle 2 will reach to a similar position on its path, and similarly part 3. And when these particles are joined, these will always form an equilateral triangle due to symmetry. And consider a general situation. Suppose 1, 2, 3 make a general equilateral triangle of side S, and what we are going to do, we are just finding the time when 1 and 2 will meet. At the same time, 3 will also come and meet. Okay, so consider only 1 and 2, particle 1 and 2. So the separation S will change. Consider just 1 and 2. So 2 has a component of velocities. 1 has velocity u. Particle 2 also has a velocity u, but it is making an angle 60 degree with the line joining 1 and 2. So we'll do components of this velocity, the particle's velocity at 2. So its velocity is u, its component will be u cos 60 and u sin 60. Forget about u sin 60 because it's perpendicular to the line joining 1 and 2. So these two velocities will obviously change the separation with this rate. Both will decrease the separation, so both will come with a minus sign, and it's minus 3u by 2, and the rest is mathematics. Simply cross multiply, then integrate both sides, put the initial limits. When time is 0, initial separation is a. When time is t, suppose the separation goes to 0, so t is the meeting time then, and solve for t, you'll get 2a by 3u. Okay.